Okay, we're most of the way through. We have a couple more lessons after this for the Unit 3. And this is just compound interest that's continuously compounded. So that means it's compounded, keeps being compounded and quicker, which brings us to the idea of what's called a limit. Now, typically you don't learn about limits until calculus, but in order to understand compounding continuously, I have to explain what a limit is. There's a very famous puzzle out there in mathematics that deals with limits, and that is, suppose you're 64 feet from a wall. I'm going to walk towards the wall, but I'm always going to take half the distance that I am to the wall. So in other words, on the first round, I'll go 32 feet, halfway up 64, and there'll be 32 feet left. And then I'll go half of that, which is 16. And that means there'll be 16 left. And I'll go half of that, which is 8. And I'll still be 8 feet from the wall. Then I'll go 4 feet from the wall. And I'm still 4 feet from the wall. I'll take half of that, 2. Half of that's 1. Half of 1 is half. Then a quarter. Then an eighth. And as you can see, it's going to keep going smaller and smaller and smaller. But I'm never really going to reach the wall if I keep going half the distance. That's kind of an idea of what a limit is. But even though I'm never going to get to the wall, I am approaching the wall. So it's going to approach something, like in this case, I'm approaching the wall, even though I never reach it. So that's really what a limit is. Let's go through some examples here. So I have this quadratic function, and I want to know, as x gets bigger and bigger and bigger, increases to infinity, means to get bigger and bigger and bigger, what happens to the value of f of x? Well, let's explore this. Take out our calculator. And we'll go to a calculator page first. Now my function was x squared plus 3x plus 5. So if I put in, I'm going to put in a number for x. You hit Control, and then this little thing right here, you'll have set equals. Okay? And I'm going to set it equal to, let's say, 10. Now, every time I put in x, it's going to memorize it as 10. Okay? So 2x would be 2 times 10, 20. Okay? Now for this, I'm going to do x squared plus x plus 5. Okay, 115. So if x is 10, then function f of x is 115. So now I'm going to try a bigger x value. So let's try x is 100. Now if I go up to this and hit enter, it'll retype it in for me, so I don't have to do it again. So 100 would be 10, 10, 5. So 100, 10,105. All right, let's try x is, let's go 1,000. If x is 1,000, then the equation f of x would be that number. Okay. Now if I continued this pattern, I put 10,000. It's going to be this number. So it's going to keep on going. Now I'm going to put put 10 zeros in there. So x is my function would be See, so it's getting, what's happening as x gets bigger. So as x gets bigger or gets closer to infinity, which is this symbol, sideways 8, as x goes to infinity, the function gets bigger and bigger and bigger and bigger forever. So that also goes to infinity. Now, that's not always going to be the case. It may approach a number. Okay, let's try example 2. So now we have this function, 6x minus 1 over 3x plus 2. We want to know, as x approaches infinity, gets bigger and bigger and bigger, what happens to this equation, this function? So we'll do the same thing. So this time my equation is, do that controlled division and it'll make a fraction. So 6x minus 1 over 3x plus 2. Now, let's start with a smaller x value just to begin with. We'll set x equal to 100. Let's see what happens. So if x is 100, approaches 599 over 302. Now this is going to be difficult because you don't really know what that is as a decimal. So we're going to hit Control Enter. So we'll put that in there, hit Control Enter. So 1.98344. 1.98344. Just drawing a table. This is with x is 100. Let's put in. We'll go a little bit. Let's go 1,000. So now I'm going to put in x as 1,000. $1.99833. Let's put in 10,000. $1.99983. Okay, so we kind of get a pattern here. Let's go really big. Let's go 1,000,000. Actually, I'm going to do 100,000, I think, first. No, we'll just do this. So I have 100 million, so 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8 zeros. Let's see what our function is now. Oop. Disregard the last one. This one right here. It's close to 2. In fact, if I went up to it, it's probably not exactly 2, so I'll calculate it rounded. So this is what I got. To figure that out, I just went back up to 2, and hit enter to paste it in here to see what it really is. So I'm getting 1.9999999. So this gives me okay. So now I would expect that if I put a bigger and bigger number, this is going to approach 2. So as x approaches infinity, f of x, this function, approaches 2. Okay, that's a limit. You try example 3. Make sure you pause this video and try it on your own to see what happens. Okay, when you put this in your calculator, if you put in x values and you got them bigger and bigger and bigger, this means the limit as x approaches infinity, which is what we've always been doing. So as x approaches infinity, so it's just a notation thing. Where does f of x approach? And if you put bigger and bigger numbers in here, it should approach infinity. Okay? That should make sense, because if you look at this equation, just in an analytical view, you take 2 squared, 4. 2 cubed, 2 to the 4th, 2 to the 5th. You should know that these numbers are getting bigger and bigger and bigger. It's never going to get smaller. It's never going to approach anything but infinity. Okay? Another way to look at it is to look at its graph. So if I went to 2 to the x, so if I graph 2 to the x, notice as x values get bigger and bigger and bigger, this goes bigger and bigger and bigger. The y values get bigger, function values. So it increases towards infinity. Okay, so graphical means you can also look at it, or a table. You can look at the table. Okay. Final example. Notice this is still notation. This means as x approaches infinity, what does the function approach? So try this one on your own. Okay, so if you did this by graph, you'd see something a little strange that happens in the graph. And if you take calculus at college, then you'll see what this means. But here's what the graph looks like. It's kind of funky looking here. So in between here, a lot of stuff happens. But in the long run, in infinity, if you look at the graph, it almost looks like it's approaching maybe 2, a little over 2. But let's see if we expand this, we keep going. Well, maybe it's getting closer to 3. So the graph's hard to tell, so we're going to do this algebraically. So I'll put in 10 first, and I get 2.59. So let me put in, you don't have to start with 10, you can do any number. And it doesn't have to be multiples of 10 either. I don't have to do 100, I could do 500 if I wanted, or 502, 607, anything. Just getting it bigger, bigger, and bigger. So let's do 100. 2.7, okay. Maybe it's approaching 2.7. Let's try 275, something. Let's try 1,000. 2.71, okay, so it's not increasing as much. Let's try a really big x value. So what is that, 1,000,000? 2.718, okay, so maybe it's 2.71 it's approaching. Let's get x to be really big. A bunch of zeros here. Not sure what happened there, but there we go. Let's see. 1. That does not seem right, huh? Maybe the calculator can't handle that many zeros. So this happens. Let's just back off a few zeros. Well, it looks like it's approaching 2.71. I think the calculator's having issues with that many zeros. So as it turns out, the calculator can only handle so many zeros, but it is approaching this 2.71 number. So as x gets closer to infinity, f of x is approaching some 2.71 number. What this 2.71 number is another number you'll talk more about if you take pre-calculus. It's called e, just like pi is an irrational number. E is also an irrational number, 2.720. Okay? So it's actually approaching E, but 2.71 for this class would be fine. Okay, you're ready to do this homework. Make sure you ask questions if need be. This is a new type of mathematics for you. Make sure you take good notes. And do attempt these problems as well as the homework problems before asking questions. your luck.